Okay, so let's go to the last part of chapter 1, that is current amplifier. So what is current amplifier? So remember, your voltage amplifier relate to Thevenin, right? But your current amplifier will relate to Norton. What is the circuit of Norton? We have this one, a current source IN in parallel with your Rn, and this will be connected to your load. So if you look here at the output part here, it looks almost the same with the Norton current. So that's how you differentiate between voltage amplifier and current amplifier. For current amplifier, so instead of voltage source here, now you have a current source, and the denotation of this current source will depend on the input current, that is IE. So here is the IE, and the output current, that is I out. So what will be the value of this dependent current source is the gain, that is the current gain. So your current gain here is denoted by II equal to I out over I in. So this is what we call current gain. Please take note, this current gain, we don't have any unit because the unit will be cancelled out each other. So there will be no unit for the gain of the current amplifier. What will be at the output? So the output will be Norton, means you have this dependent current source. It will be parallel, the Rout will be parallel to this dependent current source. And your output here will be in terms of current. Your input also will be in terms of current. So this is why we call this one current amplifier. Okay, so let's do one example here. So it's saying here the output short circuit current. Okay, recall back your voltage amplifier. We always say open circuit voltage or open circuit voltage gain, right? Because this is Thevenin. For Norton, we always call short circuit. So with the output short circuit current of the current amplifier is 255. So what does that mean? Is the output current here. The output current here. The output short circuit current. So this circuit doesn't have any load. This is the open circuit, right? So we call I out output short. Why short circuit? Because this is a current amplifier where it relate to Norton, right? Output short circuit current equal to I out. So your I out is 255. If the current gain, then what is minus 50 means? Means this AI. AI here what we call current gain is minus 50. What is the input current of the amplifier? So you know the gain of the current will be I out over I in. So we need to find I in, right? So I in will be I out divided by AI. So I out is given output short circuit current is 255 milli divided by the gain, that is minus 50. And then you can get here your I in is equal to minus 5.1 milliampere. So what does that mean? The input current here is 5.1 milliampere. So let's move to the second example. So second example says short circuit current gain. So short circuit current gain is 30. So what does that mean? AI equal to 30. Output resistance of a current amplifier means the inside the equivalent circuit, so we have R in, AI, and R out, right? So the R out here is 2.5K. Determine the output voltage, means the question 1 V out when its output is connected to a load. So in this circuit, there is a load connected here. So you cannot denote, when the circuit is having the load, you cannot denote I out equal AI. Okay, so you need to have a current divider at the output voltage. Given also the input current here is 0.5 milliampere. So how are you going to solve this one? First, in order for you to find the value of V out, you need to find the value of I out first. So how are you going to find the value of I out? You need to use current divider. But first you need to know also AI. What is the value of AI is 30. What is the value of II is given here 0.5 milliampere. Okay, so you need to know what is the value of V out here. So in order to know V out, you need to find the I out. So where is the I out? The voltage current across the RL. So by using current divider, I out equal to opposite resistance R out divided by R out plus RL multiplied by AI. So what is your R out? 2.5K divided by 450 plus 2.5K multiplied by, what is the gain here? So this is AI. Gain given in the question is 30. What is the input resistance here is 2.5 milliampere. And then you can get the value of I out. Okay, so there's some correction here. I in is not 2.5. I in here is 0.5 milliampere. 0.5 milliampere. Okay, so you can get here I out it will be equal to, so yeah, I out will be equal to 0.0127 ampere. And the question one, V out, right? So V out across the load. So just multiply I out with RL. Then you can get 5.72 volts. So this will be the output voltage of the circuit of the current amplifier. Okay, so for the last one is the transconductance amplifier. This is just for extra information for you. So for transconductors, so we have the gain is equal, output is current, input is voltage. So when the output is current, here is a noted, right, like a current amplifier. And we have another one, trans-resistant amplifier. The output is voltage and the input is current. So this is just for extra information. And the last part is the signal source or generator. So at the voltage source, we have the circuit like Thevenin, right? So Vs and Rs is in series. But if you have a current source or current generator, your resistor need to be parallel to the current source. So this will be the end of chapter 1. So as a conclusion, what have we learned in chapter 1? The difference between electrical and electronic device. Electronic, we have extra information. Which one is having power supply, need power supply, there is active component. Example is transistors and diode. And you learn about voltage amplifier and current amplifier. Okay, that's all for chapter 1. Thank you all. Assalamualaikum.